support third-party libraries and APIs. For example, if I'm using a third-party API in my application and I want to iterate the members of a class inside this API to check if some function is there, if I know the name of the function.
Yeah, even if you don't know the name of the function, you can enumerate your third-party's API and look for patterns, or yeah, it's up to you. This brings a problem because you can even look at the private members, right? And no one likes that, which is why we have this thing where you can audit for the fact that you do that. Like I know several shops who say you cannot use unchecked. Right? If unchecked shows in your code, no. You'll probably also start having your provider say, listen, if you look in our private part, we're not going to be friends anymore. Our next release might break you. Right? So there's a choice there. What I haven't shown you today is that we also provided an annotation system. Right? So that you can, instead of, you can annotate the parts of your data of your data structures that you would like that you expose to reflection. For example, if you hash a class, maybe some members shouldn't be hashed because they're not relevant to the value. You can do that through annotation. And annotation is completely customizable.
Okay, thank you. And a follow-up: will this work out of the box for old libraries, for example, or the library itself has to be implemented in some
No,
way?
it works for any C++ code.
Yes, thank you.
Thanks. So my question is there any hidden cost or runtime cost? Like I remember from back in the day, like we didn't want to use like dynamic cast because of our TI cost and so on.
No, it is completely compatible.
Okay, I have just two more follow-ups. First thing is the previous question about the libraries. Compiled libraries as well, or they should be compiled with 26 C++26 compiler?
Well, you will need to C++26 compile to get the reflection library. But if the code is old code, that's fine. But you're going to have to pound include meta, which is presumably not available in C++ remote. Maybe some compilers will retrofit it, but you need constant val functions, so you probably won't retrofit beyond C+20. And even there's some details about constant val functions we didn't quite get right in C+20, but in C+23. So I think you can retrofit C+23, but before that, probably not.
And my final question for simple uses of reflection, can we skip the reflection operator, like the double houses, and just pass the variable I want to know the name of?
Not yet. This is something that comes up sometimes. Like like pass by reflection. So you put on a parameter, hey, just if I pass something, just take the reflection of it instead of the thing. We're thinking about stuff like that. We're subtleties. Our main goal right now are like this one paper about macros. And I'm not talking about preprocessing macros. I'm talking about Rust-like macros, Swift-like macros, or language macros. We're looking at that, but we're building that on top of injection. So right now, our number one thing is injection.
Hi, thank you for the talk. You mentioned that everything is one type, so whether it's an anonymous namespace or a class or whatever. What happens with what do the functions return when a specific property is not relevant for example, if you get the identifier of a nameless of an anonymous namespace?
Okay, there's two cases. One is you ask a specific question that just doesn't apply. Like you say, are you a const qualified type to a namespace? You have two options there. We could say, well, no, you're not that, it's a namespace. Or we could say, that even doesn't even make sense for a namespace as a question. Right? So for most of the yes, no answers, we just say no. Because for all the others, we can actually throw exception that compile time is equal to something, and so we're going to throw you an exception. And you can catch it at compile time or not. If you don't, the compiler is going to give you in the error message the exception that you threw. And I should credit Hannah Dushikova, who made that possible in C++.
David, you also build compilers not just languages, but also compilers. Does this reflection feature make it easier for you to write compilers because things are more generalized?
Unfortunately, no, because remember how I changed my title? Or really, like 2 months ago, I still thought I could convince, well, maybe not convince, not very well. I thought I could change the specification so that the specification actually said December 10. It turns out that was not practical. It was too strong of a change. So the line, like my compiler still has to work based on specification. I think the way it's going to help me is that people are going to put fewer extensions in the future because you can now build your own extension in a way. So hopefully, fingers crossed.
Are there any substantial core language features that are now just completely superfluous because you could implement them with the library now?
I'm not sure how substantial, but
Virtual functions?
yes. Well, okay. So this is it's one of the things we want to do is tag erasure, automatic tag erasure. There is a video, CPP talk I gave, or like late last year, and I refer you to that. We can't do it yet with this. We need better generation facilities. As I mentioned, I think some of the smaller template features that we could have avoided, like the back in, let's say, we have all kinds of new template parameters now. We don't really need them anymore, but it's fine. By the way, this is Nathan Myers. I am here because of him. Nathan, you invited me to the committee back in 1995. And if it weren't for you, I probably wouldn't be here.
Other questions?
I can ask a question. That question I have probably 2 minutes. What is your expectation? What people would find it difficult to accomplish with C++ 96 deflection?
I'll tell you what is the hardest part that I'm seeing for people who are starting off with this. They send me code and it's not working. And I already had it before. You know, constant value functions, you can say constant value f takes int n parameter, and then something that a lot of people want to say next is like, I have an array of length n. And surprise, it doesn't work. They're like, well, it's a constant value function that n is constant, right? But it's not constant at parse time, it's constant when you evaluate it. The same is true for that splicing operator. That splice operator needs a constant as in an array dimension, as in a template argument, not a constant as in something that comes to a function. And so you'll feel that constraint when you program. You're like, I really want to take that parameter and stick it in a, but I can't, you'll get an error. There are ways around it, so you have to learn these ways. But I think that's going to be the first barrier of entry. Once you get that idea, once you understand, oh, that's why I can do it, and you get a little creative, then you'll find ways around it, and you can do a lot of stuff. Generation, like actual code generation, is you'll find you want to do that. Like we call it automatic type erasers. It's something almost every shop wants, and yet we don't quite have the tools to do it well.
If there are no more questions, let's thank the lead again.
Thank you.